But if I exit, we will lose the content of the recording. So we'll go on. Are you seeing the slides?
Yes, we can still see them.
Okay, I'm sorry for that, but everything is scrambled. I have just one window with one people closing parts of the screen. So the concept of file. Let me show you the most important concepts. File is an abstract concept and addresses what? So the name file, so forget the file as a file on a hard disk. File can be, regular file is the traditional hard disk file, permanent chunk of data in a secondary memory. Special file or device. Special file or device is still a file, but is the interface with the device driver. You will have some information about the interfacing the kernel and writing a device driver in the real-time course. Also in this case, the name is a file. So the file is the name of an interface. And you can open and so on, and write and read. You can use a file as a shared memory. So reference to a blackboard in which many processes can, at least two processes can have shared access to memory, to the same memory. A file can be a socket, that is the POSIX connection to in the internet, or in general in a network. Can be internet or other kind of network. Connection, and the name socket, the typical of home appliances, is recalls or stresses the fact that you can plug and unplug the connection, but is in any case is a file. And last, a pipe is a serial IPC channel, serial in the sense that all data are exchanged in serial, just like a reading and writing from a regular file. So these are the several meanings or several definitions of a POSIX file. So when you open a file, now we open for a regular file in our exercises, but you will go to opening connection in internet. And the concept underlying the concept of file are directory, file system, physical file system, virtual file system, and so on. We will address some of them. This is the kind of typical file system of a Unix model, in which names, all those names are file names. Some of them are directories, but inside directories, not indicated here, there are files, traditional files, but there's no difference in the Unix architecture. I will show you after a scheme of that. This is a traditional, is not POSIX defined, but it's typical typical structure of a file system, of the root file system in Unix, in which all users are in a directory that is called generally home, and there are directory that are whose name is standard. One is bin, that contains the most binaries, as to say, the executable, and part of the binaries are in another file system that is called USR bin. Another important file system is proc. You will have some information about that, and several other information. This is an example of a real mounted file system. opening, closing, reading, writing, related action are carried out by the same primitives. For example, writing on the terminal window, writing on a regular file, exchanging data with the process, sending data to a machine in the internet, writing in memory shared by two processes. And so the write system call that we have seen in the previous slides is just a universal, as well as the read system call, is the universal way of exchanging information of the kind data. And I wanted just to show this one, even if I cannot see completely, because there is the window with one of you that erases part of it. In any case, I want to point out, you're familiar with this picture. That is the structure of the kernel, or what, not here. And the idea is that here, that is input-output drivers, interrupt handlers, what they are, system calls, they are the level to which our processes communicate. System calls connect in general to drivers and handlers. The switcher is working just after a system call has been asked to perform, and upon return of the system call, there is a process table and ready queue. The ready queue is the queue in which the switcher finds the first process to run. Process table with description of all processes, but is also this part, and the last part I want to point out that clarifies the fact that the kernel we are considering is a kernel based not only on processes and on routines that execute code, but also on files, because the file is a central abstract concept in the kernel. So we have seen why, because everything is a file. Everything includes communication is a file, except for events. They are called signals in POSIX. They are software interrupts. But all other information flows using files, the concept of file. So file is so important that is inherently and implicitly part of the kernel, and is managed by the kernel side. The file table is the file in which all possible files of any kind are referred to. If files are on a hard disk, but only if the files are on a hard disk, I don't have the stylus, so I write with the mouse very roughly. This is the hard disk. When files are on a hard disk, they are the structure of all files in hard disk, including directories, is a series of identity node called inode. They are the elementary chunk of information on a disk. But this just if you are referring to files on disks, and buffer pool is the same. Is the directory of where identity nodes lie on the disk. But the file table is the table of all existing files, regular files or channel files and so on, while the process holds the file descriptor table. The file descriptor table is just the table, dimensional array, a vector with the numbers of file descriptors, and file descriptors point to file in the file table. So when we open a file, we ask the system to access the file table to find out this file, to give a file descriptor that will point permanently to that file in the file table until the file is closed. So is really the file descriptor is released when the file is closed, and any operation referring to that file descriptor goes into the kernel and finds the table pointed by that file pointer. So file pointers are, as a matter, universally identifiers of all communication channels apart signals. So all communication channels, including that support data transfer, are managed by file descriptors. And you know that file descriptors can be aliased. So the DOP primitive, and it will be the next argument tomorrow morning to explain how to make two processes communicate using a file, not a regular file on disk, but one of the virtual file that is a communication channel. Okay, for today, I think we are over. If there are not questions, I still ask you to read the slides, including also the slides that we didn't discuss today. Tomorrow we will start from fork exec. The exercise will include exec and exchanging open files, but we will very soon face the communication between two processes after forking. Okay? Questions? I hope that the recording today is okay, because the problem, as I told you, is that the interface, the Zoom interface, is completely scrambled. But I stop recording now, and I will see if the recording is okay. In any case, I will publish. Okay? See you tomorrow.
See you
Bye-bye.
tomorrow, Prof. Have a
Bye.
nice